Okay, so here we have a waterfall. This is man-made, and I forgot my microphone, so I'm going to talk very close. But yesterday, I should have got a video, but this was, actually not yesterday, earlier this morning, this was the same elevation. So, there's so much water, and this is what's going to happen with climate change. It's going to have so much rain when it does rain, because the heat can hold more water, because it's going to be hotter, it's going to evaporate a lot more water, and so there'll be a lot more water in the skies. Not only a lot more water, a lot heavier water. You can see how thick the clouds are now. That definitely rain cloud. Here, not really. It looks like coming from down south is another thunderstorm. And just behind that house, you can't really see it, but I can see it with my eyes, but the camera's not that good. Maybe another 100 years we'll get really good cameras. It's really dark clouds, so rain's coming our way because the clouds are coming from the south. You're probably thinking, oh, where's all this rain coming from? Where's all the water coming from? A lot of people think that, you know, these rivers just have water that comes from them and upstream. But a lot of people really don't think about this. The water is actually also coming from the sides of the river, so the bank. So over on that grass, underneath, and underneath those houses there is water. So there is water stored underneath, because a lot of this rock, a lot of the soil is porous. That means it has holes in it, cavities. So it has gaps where the water can get in. And as the water gets in, goes down, and it flows to the lowest point, and the lowest point is always the river. So this is the lowest point in the land here. Even though this is quite flat, it's still the lowest point here. And it's also the point where a lot of the erosion is taking place that you can see, because it is the biggest gap between two sides of the actual rock. So it's just like a big hole really here. And also where the water level is the water table. And there is a water table underneath those houses. But the water table is higher. And this wind, when it actually blows, it's actually blowing the water over the river. And it's actually blowing more water, and you can actually hear the, when the wind is in full force, it actually quite larger sound. Oh look, we have a rainbow. I wonder if I can find some gold over there. I probably wouldn't find any gold. I'll probably find some fool's gold actually. Which, yeah, I forget the other name of it. So anyway, what were we saying? I forgot what I was talking about. Okay. Anyway. Yeah, so there's water coming from the sides of the river. Oh yeah, the water table. So the water table under that house is just a little bit higher than the actual river. So it's where gravity will force water to come downwards. So you know, gravity likes to go down here. The same as, you know, you're on a hillside and you come down to the river. No, you're on you're on a hillside and you go down on a skateboard or a bike, same principles pretty much, except you need to go through rock and soil, which gives it some resistance. And here is Mr. Goose. So he's just had some bread, so he's quite happy. Okay, so yesterday this log was almost submerged. So where those reeds are is usually free of water, and as you can see there's so much water now. So the water, you can see how damp this is, so this water is slowly flowing into the actual lake. So it's basically aquifer systems, and you can see the lines, so the water actually probably come up to here. So usually there's enough room there for the actual swans to get through, but now they can't. So once again, when people look at a river, they think that the water just comes from upstream, because have a look at it. There's a lot of water coming down. It's quite fast flowing and very rapid. But if you look at the rocks over there, these have lots of cracks, but you don't see it there is water actually coming out of those rocks. Probably it would be deeper down into the earth. And there's also water coming from up there because it's just recently rained in the last 2 hours. So there's fresh water actually going through that soil and through the rock. And it's actually flowing. So it's flowing down into the actual river. So once again, here's a good example where you got water flowing from upstream but also flowing from both sides into the river, and it's also coming it would be leaving the river system down below. Unless this is the water level. So this is the water table. So the water could also, depending on the actual aquifer, be coming up from down the bottom. So it depends on the actual geology of the place. So sometimes a river system can be a discharge for an aquifer. Sometimes it can be a recharge. It can also go down or up. So that's a different. With this type of rock, so this is basalt. So if we look at the actual rock, so the soil is quite damp. So this is the basalt, Montmorillonite clay this is. Lots of organics, that's why it's quite dark. So there's a lot of water percolating down. Some of it's going to be kept in the pore spaces and be evaporated. But if we look at the rock, so in this type of aquifer underground, the water could be travelling through the vesicles, so the air bubbles, but not. The air bubbles only occur mainly in the top where the rock basalt solidified quite quickly. As you go deeper down, there's less vesicles, and usually there's none as you go deeper. But as you can see, the rock has fractures, and in this type of formation, the water will most likely just be travelling through the actual cracks in the rocks. And because those cracks, as you can see, they're quite well defined, and they're also quite separated, so the water can travel pretty fast through those. But if it's travelling through pores like in sandstone, okay, there's sandstone over that way, it would actually travel, so you can see the actual stratifications of the formation, so the actual beds of the formation. So the water would actually travel through that rock, which is a siltstone. So the actual holes are actually very small, so it would go quite slower than compared to the basalt, which pretty much is like just driving down the road. And this one would be like, I don't know, trying to find a car park when the car park is almost full. So that's an aquifer system. And this sandstone that you can see here, not sandstone, siltstone. Oh, it does have some sandstone in it. Most of it's siltstone. And some claystone. And the basalt formation that you see here, both of their discharge and recharge are different because of the different types of rock. So I hope this helps you with aquifer dynamics. It's just a basic introduction, but you can see you've got two different types of rocks, and the water flow through them is also quite different.